as you know, the module is organized around 4 different themes. Last week, you completed the Web of Data theme with Pushpa. And this class will be part of the IT Fundamentals theme. And we will be looking a bit at the dark side of computing, which is hidden usually from the users. As usual, start this lecture with a bit of feedback about your progress and the work you started last week. So now the marks have been published for the first 10 activities, so that's all the activities of teaching block 1. So I wanted to share some statistics with you. So first, we'd like to congratulate the 50 students who have passed all the activities. So they are on course for the top mark. On the other side, 20 students are so far below 40% of the maximal mark, and as a consequence are at risk of failing the module. So if you are in that situation, I would urge you to contact me so we can discuss how to catch up. It's not too late, but it's getting hot. Unfortunately, the number of students, as you can see, who are passing the activities is going down. So it's not a good trend. So hopefully it's going to go up again. And the last activity was a bit better than the previous one. So hopefully that's part of the New Year resolutions. Of specific concerns have been those 3 specific activities. All of them has to do with programming is really a key skills for any IT professional. 2 of them had to do with web prototyping and 1 with creating an app. So I really urge you to make an effort on the programming part of the module. You know that you have supports with your mentors, and I think that's the person to contact to spend a bit of time and discuss any issue. If we look at, in terms of marks, there are still 3 activities which have to do with web prototyping, worth 12%, and there is a larger piece of coursework at the end of the year where you will be building a website, and that's worth 30%. So there's still a lot of programming in this specific module, and obviously since you are on an IT course, you will have programming until the very end of your degree. So for those who are a bit behind, please make a special effort on these. So regarding activity 14, so that's the one which was set last week by Pushpa, and this week I'm giving you some early feedback. So then you still have 3 weeks to try to improve and maybe resubmit your work if it was not satisfactory. So the theme was big data and data mining, and 50 of 1 have completed that activity by the early deadline. Most of those submissions were actually of very good level, some great discussions about data mining. So most of the people who submitted actually passed. Some of you, unfortunately, did some work which was a bit, let's say, superficial. So I've contacted you directly by email telling you the points you should develop further, and you still have 3 weeks to resubmit with a better submission. If we look at the different data sources that you have used for big data, Facebook and the Oyster cards have been the most popular. Quite a few people use Twitter, Instagram, and Amazon, and 1 person eBay and 1 YouTube. Regarding the feedback you gave about this activity, good and interesting, a bit tricky, and that's basically what we want. We want the activity to be interesting. We want you to learn during the process. We want to challenge you, and I think your comments somehow reflect that objective. Some of the interesting facts you have reported, because it was very interesting to read your submission. So I've learned that more than 60 million Oyster cards have been issued since 2003, that Amazon processes more than 26 million items every day, which is pretty incredible. 600 million active users on Instagram. The amount of data that Facebook is storing every day on users. And we should remember the ethical issues which are behind all that. And the number of tweets which are produced every day. And I guess this trend is increasing seriously. You had a few questions. Some of you were not quite sure how to report those data, those facts. Did I expect, for example, gigabytes, terabytes, some kind of hard number, or just statistics? And really it depends on the fact that you are reporting. If we are looking at how much data Facebook is generating, it may be interesting to know that Facebook is, for example, producing 5% of the traffic of data on the internet. That's maybe something quite interesting. Whereas if you give me the number of terabytes which is circulating, it's maybe less speaking to the person reading the report. On the other hand, if we look at the number of Oyster cards, a hard figure is something which is more relevant. Some people wanted more. They got quite excited about that theme of big data and wanted to investigate a bit more. So here are a couple of sites that you can have a look at if you are interested in open data. So that's all I wanted to say about the feedback of the previous activity. As I said, you still have 3 weeks. So now let's start our new theme, operating systems. So if we look at the different definitions of operating systems, it's basically a layer in the computer architecture that very often users are not really aware of and not interacting directly with. Okay, because you have the hardware, so that's the physical part of the computer. Then you have the operating system, which is interacting with this hardware. Then the applications you are running on your machines interact with the operating system, and the user is actually interacting with the application. So the user often is not aware of what's going on in the operating system. And that's good, because the aims of the operating system is to execute applications. So you want the user to double-click in an application and not worry about how much RAM is available and what is the configuration of your system. And it's the interface between the physical part of the machine and the logical part of the machine. And as a future IT professional, obviously you are not going to be working anymore at the user level. Most of you are likely to work at the application level with interaction with the operating system, making sure that the apps you are developing are taking advantage of the resources of the machine, and you are going to do that through the operating system. But some of you are likely to work on the operating system directly, because that's, as we will see later, there are important pieces of software which needs to be updated all the time. So, as I said, operating systems which allow communication with the physical machine, and now we have microprocessors in most of the devices we have around us. Okay? It's not anymore just the computer, it's your mobile phone, your car, your phone, and so on. So just to start the conversation, let's start with a a clicker question. In 1943, one of the CEO of IBM, so the main manufacturer, or the only manufacturer of computers at the time, was asked what is the world market in terms of computers. So what do you think was his response? Let's have a look. Okay, so we have your votes are really at the two extreme. So is there a world market for maybe 5 computers or 5 million computers? And the larger group is people thinking it's about 5 millions. So we should remember it's 1943. And at the time, a computer would have roughly the size of this very room, okay, and would cost millions of dollars. So basically, at the time, only superpowers could afford a computer. Okay, so we are speaking about the United States of America, Britain, Soviet Union. And that was it, okay? So maybe you want a couple for America, a couple for Soviet Union, and Britain one, and that's your world market, okay? I mean, that was a long time ago. Things have changed. So if we look at the people to computer ratio, we started with this huge machine taking, as I said, a lot of space. And so they were data processing units. So it was number crunching for usually research institutes related to the military industry. So there were those big machines and all those employees having access to that machine. Slowly, the machine became part of the standard private company to improve productivity of the company. And eventually it went to the personal computer where each employee would have a computer. And from now, where everybody has 4 or 5 computers under one form and another, which is a completely change of paradigm. So we started with 5 computers for the entire world. Now it's maybe 5 computers in your pocket. Okay, you can see that the world have completely changed in 70 years. And obviously, behind each of those computers, we have some operating system. An important point we have to look at as well is this famous Moore's law, okay? And it's quite popular. It's mentioned in the press, but are we understanding exactly what Moore's law is about? So which option do you think defines Moore's law?
It's A.
Yeah? I think it's A? Okay.
Which channel is this?
Does me?
What channel?
05. Okay. So there's a bit of confusion between B and C. So the processing capability and the number of transistors inside a computer. So let's get the definition from Gordon Moore. So Gordon Moore was one of the co-founders of Intel's. And so they were working on semiconductors, they were building chips. And they had realized that in the previous decades, every 18 months, they were able to double the number of chips within a certain area. So he predicted that this trend would carry on for a few more decades. Yeah? So that was 1965. And if we look at the early 2010s, the trend was still valid. So it's a prediction which has been running for more than 50 years. And unlike the size of the market of computers, which has gone from 5 to billions, in this case, Moore's law is still going on. Okay? Microprocessors are still getting smaller, denser, and more powerful. So if we look at the different curves, we can see that the number of transistors, that's what Moore's law is speaking about, is increasing. And for a while, not only the number of transistors was increasing, but we could make them work faster and faster all the time. So there was a double effect. There were more of them, and they were running much faster. But we can see that since the early 2000s, the clock speed hasn't changed. Okay? And the reason is the faster a component is running, the warmer it gets. Okay? And already our computers are getting very warm. I mean, if we go to the labs, we can say that the air conditioning is running at full beam. So it's not possible to go faster because we have no ways of cooling down those components. So it's becoming an issue because we cannot go faster, and we are still adding more and more components. So the heat is getting a real challenge. Okay? So now that's why the best computers, now the higher performing ones, are cooled by liquids, not by air anymore, because heat is really a big issue. But more importantly, Moore's law is going to end. Okay? So Intel, so the company created by Moore's, predicted 10 years ago that would stop around now. Okay. Gordon Moore himself said, there is a limit. Once a transistor has the size of an atom, we cannot split the atom anymore. Okay, so physically there is a limit. We know it's going to stop at some point. And the latest predictions put 2023 as the time where Moore's law is going to stop, and we are not going to gain in speed by the increase of number of processors. So that's your generation. When you are going to get out of Kingston University, you need to be aware of that. You cannot use the same idea as before. Oh, my application is too slow. I just wait 1 year, my computer will go twice faster. Okay? That's not going to be true anymore. And the manufacturers are very well aware of that. And when you buy now a PC, usually you have 2 processors, 4 processors. They know that with 1 processor you cannot get the performance and the increase of performance that you would like. Okay, so what is the most popular operating system? Windows? Any other suggestion? Linux? So, first of all, I would like to say that it was a tricky question, because that question doesn't really make sense. Okay? A proper question would be, what is the most popular operating system for PCs? Okay? Because we have seen that any electronic device as an operating system. So we are speaking about mobile phones, PCs, digital cameras. All of them will have an operating system. It doesn't really make sense to compare one with another. So in your view, the most operating system for PCs is Windows. So 94% of you believe it's Windows, 6% believe it's Linux. So in this case, you have been completely right. As you can see, Windows have around 90% of the market. Okay, you have a little bit of Mac and a little bit of Linux, but the main operating system for PCs is really Windows. So if we look at the different trends, so that was from January 2017, we can see that Windows 7 is slightly going down. Why? Because Windows 10 has been released. We will not mention Windows 8, which was a disaster. People prefer staying on Windows 7. Interestingly, quite a lot of people are still using Windows XP. And at the bottom, we can see that the Apple system has a very small share of the market. Okay? And Linux is virtually invisible in the personal computer market. So going back to Windows XP, the last release was 8 years ago, and you have still 10% of the machines still using it. Okay, so now same question, but what about mobile phones? Is Windows the leader as well? Okay, so now we are 81% Android, 19% iOS, so the Apple system. So if we look at the market, somehow it reflects what Paul is saying. Android has around 2/3 of the market, but the Apple system is still a serious competitor. And then you have smaller players which have Java system, Windows market, and Symbian, which is an operating system for the old Nokia mobile phones. So it's quite interesting that if you move from one platform to another, the players are very different. Okay, we have seen Windows, Apple, mainly Windows for the PC. Here is more Google and Apple, who are competing. And here are the trends, and they are very similar. We have the iPhone, which has a share of the market around 20% and the rest in mainly Android. It's quite interesting to see the fluctuations. Each time there is a new product on the market, there is a big jump from one system and another. So we can see that in that world, very few people have an operating system which was released for the last time 8 years ago. Okay? People are changing device almost annually, and we can see that in the trends for operating system. What about web servers? Okay, because that's another type of platform that we are using every day. So are we looking at the same players? Okay, so now we have Linux and Google. So the leader on the market is Apache, which is a configuration with, which is based on a Linux operating system. And that's why when I ask you to get a web server, I ask you to work with Apache and Linux. So in principle, you have your PC, which is a Windows operating system. And for your server, you have the ability to learn about Linux, which in this world is the leader with 50%. We can see that Microsoft, around 2005, tried to break on that market. And for a couple of years, it looked like maybe it could challenge Linux. But now it has disappeared from, or almost disappeared from the market. Something which may be interesting to note is this NG-INX. So it's also a Linux-based system, and you can see that it has been growing sustainedly since 2007. So that's maybe one to watch. Okay. But again, it's Linux-based, so with your experience in Apache, you should be able very easily to work with that type of system as well. What about supercomputers? Okay, because we still have supercomputers around, and there's a big competition every year. What are the 500 most powerful computers in the world? For a while, it was a competition between the United States and Japan, and now China has been the leader for the last 2 or 3 years. Okay. So there's a lot of pride of having the largest, most powerful computers. And obviously it allows you to do things that others cannot do. A lot of defense application, but also predicting or modeling global warming and some medical applications. So what is the profile here? It's a bit unsure. So is it Windows, is it Linux, or is it some exotic type of system? Actually, it's very simple. It's Linux. You can see that 99% of the machines are using Linux. Okay, so historically, they were using Unix, which is somehow the grandfather of Linux. And with the arrival of Linux, the machines have updated to a Linux-based system. We can see that Windows gave it a try, Apple gave it a try, and it hasn't been a success. If you want to work in an industry using supercomputers, the system you have to learn about is Linux. Okay, so we can see that Linux is for big machine, for servers, which are relatively big machine as well. For your mobile, it will be either Google or Apple, and for the PC, it's mainly Windows, even if there are some niche markets where Apple is very strong as well. So what about Mars? What is the most popular operating system on Mars? Any idea?
It's going to be a pun.
No, there is no pun.
Oh. I don't know.
Talking about the robots that collect samples there.
Yeah, so we have machines on Mars, which were sent a few years ago. And obviously they have a computer on board, and they use an operating system. Which one do you think they are using? I mean, obviously it has some extra constraints, okay? You don't want to reboot or press the reset button too often, okay? So maybe Windows wouldn't do it. So it's obviously it's a specific operating system. It's called Integrity, and it's in this category of operating system which are called real time. Okay, when something happens, they have to react, and there are priorities. You know, the probe is kind of falling because there's a hole. Now we need to react. Okay, doesn't matter any other application which was running at the time. That's the priority we need to get out of that hole. Okay, so here is the the rover, which is on Mars, it's one of them. So this one is Curiosity, was launched 5 years ago. If we look at the spec of the machine, they are not very impressive. Okay, a processor running at 200 megahertz, that's roughly what you have in your PC. Some RAM, 256 megabytes of RAM. That's very poor. I'm not sure you can run Windows. That you would need at least a couple of gigas nowadays. Yeah. And obviously, the hardware is not just a computer, it's camera and scientific instruments and a lot of stuff. Okay? So obviously, you don't want to use too much power in the computer. You want to be able to run the other devices. And obviously, energy is a big issue. They have solar panels, but you need to be able to get enough electricity for that system. So obviously, the constraints are you have all those systems running at the same time. You have some cameras trying to locate where the probe is. You have the system of locomotion and so on. So all those processes are running at the same time. As I said, you cannot hit the reset button if there is a problem with the machine. Some functions are really critical. I mean, because they are on Mars and they want to communicate with the Earth, there are only a few hours a day where they are facing each other. Okay? The probe with some aerial on the Earth. Okay? So you need to make sure that the communication is done at the time which is specified. You know? It's not acceptable to say, oh no, I'm updating a system and wait 10 minutes. No, no, no. It needs to be on time. So it was supposed to be a 2-year mission. So it has already been running for 5 years, so that's pretty good. Very good for the operating system as well. Didn't crash in 5 years. And they were supposed to find some evidence of life on Mars. They haven't found life yet, but studying the conditions, they believe that maybe some microbial life could have existed. And it's still running, which is quite remarkable. And since Valentine's Day is coming, I've decided to put this very romantic picture, a sunset taken from the surface of Mars. Okay, so what are the goals of those operating systems? So the first of all is you want the user not to be aware of it. It needs to be completely transparent. You are using a machine, you are your own PC, you are going to the library. You don't want to wonder which operating system am I running. Okay? Just to double click and the application should be working. And it should be working on your machine, on the other machine. Maybe the RAM is different, maybe the processor is different. It should be completely transparent. The hardware as well, you don't want to worry about the hardware, and you want your application to make best usage of your hardware. If you have 2 microprocessors, hopefully the operating system will speak with your application and say, hey, I have 2 microprocessors on this machine, please use them in order to get better performance. Obviously, when you have a machine, you have a lot of applications running at the same time. So the operating system needs to make sure that resources are shared between these different applications. That's really a key task of the operating system. As I said, you want having an operating system allow you to move an application from one machine to another if they use the same operating system. So that's one of the reasons why in the PC market, Windows is a large, the leader, because you want to be able to share application with your friends and stuff. So having the same operating system is really important. And another goal, which is a bit hidden, is about security. Okay, first of all, you don't want different applications to interact with each other if they shouldn't. You don't want one to crash and crash all the others. And also you want to be protected if, for example, you are connected on the internet from the outside world. And obviously you want to be reliable, you want to deal with errors. I mean, it's a physical machine which can make errors. So make sure they are confined to an application, that they don't spread across all your applications. Deal with faults and maybe reconfigure it if there are new devices and so on. Okay, so at the end of the teaching block 1, we look at the hardware, what were the different components of a computer. And so you have all those components, and they have to communicate through a memory. So you have this bus, this common bus, and all those devices want to access to the memory. So obviously, your operating system has to have some kind of strategy allowing one or another to communicate one after the other. So when we look at operating system, depending on how we use it, we can see it from different angles. So for most people, it's a way of allocating resources. Okay, I'm running many applications, and the operating system is going to make sure that all of them have the resources they need. It's also about controlling program, make sure that there is interaction. When I press the keyboard, that automatically this action is taken into account and will activate the appropriate program. But for some people who are more the developer of operating systems, and some of you will be doing that in their professional life, an operating system is this big applications which runs in the background, which never stops, and make sure that everything is fine on my machine. So let's take a very basic case. I have one microprocessor, and I want to run several applications at the same time. Okay? So basically, I need to write my report, but while I'm writing my report, I'm listening to some music. I'm alerted if there are coming emails, and maybe there is my Twitter account running in the background. So I have several applications running at the same time, but physically, I have only one processing unit. Okay, so how to deal with such a situation? And the solution is multitasking. Okay, so several jobs share the system, and the operating system makes sure that it moves from one to another in a very smooth manner and according to the need of different applications. Because if you want to be aware of the arrival of a new email, for example, if you get the announcement 10 seconds after it has actually arrived, it doesn't really matter that much. Okay? But if you are listening to some music and you get the next note 10 seconds after the previous one, that's a big problem. Okay? Or when you are using you are writing your report, each time you type a key, you want that the outcome to appear on your screen. It doesn't need to be instantaneous. There are a few milliseconds. There's a bit of time, which is acceptable. But so each application has different constraints. In the music application, you really need everything to go very smoothly. With not much time between the different set of data arriving. When you are using the keyboard, you have a few milliseconds where in between two keys, the system can try to do something else. Checking your emails regularly every few seconds, every few minutes, that's a completely acceptable behavior. Okay, so time sharing, so it's using that physical resource and share it across applications. Sometimes some applications interact, which make the task even more complex. But sometimes it's also you have one machine and several users. So typically you have a web server, you want to access the data, and you have a range of clients trying to access that server at the same time. Okay? So you need to develop an appropriate strategy so that the quality of the service appears as good. Okay? So some of the parameters you want to try to optimize when you are dealing with scheduling tasks is you want the system to appear to be fair. Okay? You are connecting to a web server. You don't want to have to wait 15 minutes for the previous user to get access to it. On the other hand, if you were the first to log in, you think that you should be somehow the first to be served. The scheduling has to deal with differential responsiveness. As I said, you tap your keyboard, you are happy to see it appearing a few milliseconds. You will not detect if it's not instantaneous. Music is something else. Getting alert about of emails is very different. And you want it to be efficient, okay? Because if you want to be very smooth and fair across all your applications or users, you can swap from one to the other all the time. Okay? However, each time you swap, there's a lot of work going on in the background. You have to save the current state of your application, put it in memory, get to the memory of the next application you want to run, load it, and then run that application until you swap again. Okay? So you have this overhead of moving from one application to another. So if it happens too often, your computer just spend their time swapping things and not working on the application. So you need to have a good compromise. So we were going to look at different type of strategies that operating systems are using. So we are going to look at an example. Let's assume that we have a single CPU and we have 5 tasks that we want to complete. So here we can see the time when we would like the task to start, and we can see the duration of each task. Okay? And we would like to find a way to run those 5 tasks in a way which appear to be fair, following priorities, and so on. So the first strategy, the most basic one, is the first in, first out. You have a new task arriving. If the processing power, this task is processed first. Once it's completed, the next task which has arrived will be processed. Okay? So we will arrive at such succession of tasks. And in one way we could say it's fair. The first task was processed first. Okay? But on the other hand, you can imagine that you have tasks which are very short. Okay? You just need a split of a second for completing that task. And it will have to wait all the other tasks to be completed while you have a task which may last 10 minutes. Okay? So we can understand that if a task is supposed to last 10 minutes, and you get the answer after 11 minutes, it can be seen as an acceptable time for getting the outcome. But if it's a task which is supposed to last a split of a second, and you need to wait for 10 minutes, somehow, it's not satisfactory. So if you were to use that kind of strategy, all the small tasks, would be put in the queue, and users would not feel happy about the outcome. So an alternative is to use what is called the round-robin scheduling. Basically, you run your task, and once there's a new task which arrives, you start processing it, but only for a certain amount of time. Okay? So you are designing a clock, and each task has 1 unit of your clock, and then you go to another one if another one needs processing power. So you split your task, you move from one to another, a new task arrives online, and that's how your task would be processed in this configuration. So somehow, if we look at our short task, it's not the process at the very end. Okay, so it's a bit more satisfactory. So this strategy looks quite reasonable. The issue is, what is the size of the unit? Okay, as I said, if the unit is too small, the computer is swapping environments all the time and not spending its time processing the task. Okay, if the unit is too big, then all tasks will complete within the unit. So some more advanced strategy are try to have some kind of priority idea behind the scheduling. But in that case, for each task, there is a predicted processing time. Okay? So you send your task, and you say it will last that amount of time. So now the system knows, oh, it's going to be a long task or a very short task. So if it's a short one, yeah, we can put it towards the front of the queue. If it's a long task, we can wait a bit more. Okay. So that could be an example how it would be implemented. So now we have seen that our shortest task has been processed 3, so has moved in the queue because the predicted time was short, so the system decided, let's allow it to be completed earlier. Issues with that strategy is you need to correctly estimate the time of your task. Okay? You tell the system it's going to be a short task, and the system gives you that amount of time, and your task is still not completed. What does the system do? Kills your task. Out of the way, you wanted that time, I gave you that time, bad luck, it's not finished. Okay? So you really need to be able to know how much time you want. So you will tend to overestimate the time to make sure it's going to be complete. But on the other hand, your priority will go down because your task is going to be longer or appear longer. And another issue is the possibility of starvation. Okay? If you have a big task to be performed on a machine, all the time there is a short task which will appear, and your long task is going to be put at the end of the queue, and eventually will never ever be processed if you were to use just that type of scheduling. Okay, so let's look at what operating systems do. So let's look at the case of Windows XP, but the latest Windows are using a very similar type of scheduling. So Windows XP is based for PCs. Okay, so you are in a real time, you have a person sitting in front of a computer. Okay, it's not a batch job where researchers send a huge job, go for a meal and come back to see the result have arrived. No, the person is in front of the screen. Okay. So what Windows want to optimize is the user perceived performance. You feel as a user that the system is performing well, that you get the response you are expecting. Okay? So that's the objective. Make the user happy. It doesn't mean that it's going to be fair, it's going to make the user happy. Okay, so that's the objective of Windows. So we have seen the round robin strategy. You split your task in small chunks. And what they do in Windows is you have a round robins, but with you have several queues of round robins. You have the high priority queue, the lower priority queue, so that you have a compromise between round robin, and the other strategies where some tasks get higher priority than others. So first you have the real-time processes. Okay, so that's, I'm touching my keyboard, I need a response now. So that's going to be high priority all the time. And then you have the other processes, and what you want to do is to do the round robin, but once a process has been running for some time, you are going to lower its priority. Okay, so it's a bit the idea of predicting the length of the process. Yeah, it looks like it's getting a longer process, so let's lower a bit the priority of that process. But each time you type the keyboard for a given application, priority is going up. So it's good to know when you are using Windows, if you have a process which takes a bit of time, click on the window to make sure that the operating system knows you are waiting for it, you are interacting with it, so it's something which is of quite high priority. So as I said, the windows which are at the front are the ones with high priority. So if we look at our machine, if you use the task manager, you can see that you have all your processes which are currently running. And if you right-click, you can see what is their priority. Okay, so by default, the jukebox player has a normal priority. Okay, but I can change it. So that's the way to become an expert user. You are running a big Photoshop job on a big image. It's going to take minutes. And if the machine that you have is not with a high spec, everything is frozen on your computer. Yeah, that's happened. Go there and put it a lower priority. And you will see it's going to defraud. Thanks for coming. Okay, so it's going to run in the background with a lower priority, and your resources will be available for the other applications. Okay, so that's a very important trick that you should be using when you have a big job. Reduce the priority before you run it. You don't care if this processing takes 10 minutes or 15 minutes. During that time, you want to do other things. Okay. Some jobs have, I believe, high priority. Okay. So that's some of the Windows processes. They are important. They are dealing maybe with the hardware and stuff. So Windows put them at a high priority. Okay. So feel free to play with that. Okay. You may crash your machine in the process, but that's the worst can happen. Okay. So I wouldn't play too much with the Windows processes, because if they believe that they are important and they need to be reactive, maybe leave them there. But when you are working with your own application, okay, feel free to play with it. Or again, you have this Photoshop job running. You decide to go away and go for a drink. Why not increase the priority? Because when you are not in front of the computer, you don't care that it's dealing with your browser and all that stuff. You want that job to be done. Okay? So you will get it quicker perform. Yeah. So that's something you need to start interacting basically with your operating system. What about Linux? Okay, so we have seen that Windows was about to make the user happy. I mean, it's a commercial company, they want you to buy their stuff, they want to make you happy. That's normal. Linux is quite different. Okay, so we should go back a bit in time. Linux is the grandson of Unix. Okay? Unix was developed for those supercomputers. You have one machine the size of this room, and you have a bunch of researchers sending job to that machine, okay, to do some complex computations. So we are not speaking about someone looking at the screen expecting the result in an instant. They are not sending some big computer jobs. So for them, what is important is it to be fair. Okay, we are 10 people using the machines. I want to have 1/10 of that time. Or my application is critical. My boss gave me the authorization to get that with the highest priority. I want that job to be processed first. Okay? So that's the mentality which is behind the Linux operating system. So that's why fairness is a high priority. Okay? And that's what you find on servers as well. Okay? Those configurations with big machines that don't really exist much anymore, but people connected to a web server, they want it to be fair. Okay? You know that maybe for certain servers there is a lot of traffic and you will have to wait a little bit. You may understand that, but you need to feel that it's fair. I got a fair access to the data. So strategies, again, there is round robin for everything which needs to be dealt in real time. Okay. And then for other processes, it's first in, first out as major strategy. But as soon as your initial process has run for a bit of time, it's losing credits so that another process can go in. Okay, so it's a different type of processing, so, but with a slight emphasis on trying to be fair. You arrive first, so you should get the priority. Obviously, another big aspect of computer operating system is not just to share those resources. It's also about security. You are on your web server, you are connecting to that machine, you don't want the other person connecting affecting what you are doing. Okay? Or if you are running two applications, you crash one, you don't want it to crash the other one. And then you have all the security to do with your machine being networked, hacking, and so on. And we know that Linux systems tend to be more robust to hacking than Windows systems. And again, it's because of that philosophy. The Linux system is based on Unix, and Unix from day one was about sharing a machine between a lot of people. The Windows system is coming from the PC market. At the time, everybody had that machine, and it was not connected to anybody else. Okay? It's only when the internet arrived that changed a bit things. So they are coming from different parts, and they have to deal with security differently. So that's why Windows tend to be a bit behind, because Linux and Unix were really focused on that from day one. So obviously, with all what is happening in the IT industry, you can imagine that these operating systems are evolving all the time, and they are becoming quite big. Okay, and just to run them, you need a lot of resources. Okay. So, in your opinion, how many lines of code is there in an operating system? I guess you have already written a bit of code, tens, maybe 100 lines, something like that. How much do you need to create an operating system? A modern one. Modern operating system. Okay. So it looks like the answer is, I don't know. Pure guesswork. So some people think it's small, some people think it's big, can be a bit of everything. Okay, so if we look at PCs, because that's the data for PCs. So the first Unix, so the grandfather of Linux, so it was in 71 and it had 10,000 lines of code. Okay. So it was possible to build quite a small operating system. So now I have the sizes of main computer applications. So the units is millions of lines of code, so it gives you somehow the idea. So if we look at operating system, we start with 10,000 lines of code in 71. Windows 2000, we already have almost 30 millions. Symbian, so that's for Nokia mobile phones. Already we are just below 40 millions. Windows 7, roughly the same as XP, which is quite nice. You know, in 8 years, the size of the operating system hasn't changed. But still, we are in the 40 millions. Then we move to Vista, an extra 10 million lines of code. And now we look at Debian, which is a Linux system. We are over 65 millions. And the Mac OS Tiger is at more than 80 million. Okay. So that gives you an idea about the size of current operating system, somewhere between 50 and 100 million lines of code. Okay. And so here we have all the largest pieces of code around. So you can see it's dominated by operating systems. Interestingly, the code that there is in a fighter jet is not that big compared to it, 25 million, compared to what you have in a car, which is around 100 millions of lines. Okay. You can see also Microsoft Office going from 25 million to 45 million. You can see Facebook, which is in the 60 millions. And here is the size of the genome of a mammal. Here it's mouse, but the size for humans would be roughly the same. And it's still a bit bigger with 120 million lines. But we are catching up. So you can imagine the complexity of operating system is almost the same complexity as the DNA you need to create a mammal. Okay? And the operating system was created from scratch, not through hundreds of million years of evolution. Okay, so now we have finished with the theory. We want to look at operating system a bit more practically. Already I gave you a trick for your Windows machine. Start playing with the priorities, but that's still quite easy, just a couple of clicks. What I want you to do is to move to the dark side. Okay? You know that, I don't know, when you interact with technicians, usually you don't see this nice windows. You see a black screen with lines which looks like 80s films. Yeah. Because speaking directly to the operating system without going through all that Windows interface is still the most efficient way to do things. Okay? So as future IT professional, you need to be able to do that. Okay? So you need to have the basics to say, okay, in order to perform that task, I go directly to the console mode and I'm typing my request instead of looking in the windows and try to find some, or maybe download some application to get it. Okay? So you need to go to what I call to the dark side. So that's typically what you will get on the Windows machine. That's what you will get on a Linux machine. Okay? And so here is a small task. You have a folder with a list of files and directories. How can you get the list in a text form? How would you do that?
DIR code?
Excuse me?
DIR?
Yeah, but without using commands. You know, if you say, okay, I'm just going to use clicks, can you do that? How would you do that? You know, you want to know what files you have in a folder. You want to have a list, you know, in case. You know, imagine you have a folder with where you collect photos, and you want to have a list of all the title of your photos. How do you do that? You know, it's a very practical problem. And I wouldn't know how to do it using the Windows interface. I have no idea how to do it. However, if I move to the operating system mode on the console, I can do it very easily. Okay? And I can do some very advanced stuff. You know, I want everything in this folder, everything below that folder, and I want all the files which are with a prefix JPEG, which were created in the last couple of years. I have just one line of code, tap it, and everything copied in. Okay. I could do that. If you want to do that without interacting directly with your operating system, maybe you will find some apps somewhere, so you can spend half an hour looking for an app doing exactly what you want, or maybe not exactly, but at least getting you close to that. So how I would do that? I type CMD. Now I have access directly to the operating system. I can type commands. So let's go on my Edge drive. So here is a list of all the 5 directories that I have there. And what I want is to copy everything in a file. Okay. So I'm going to do, so dir is to get the list. And using that sign, I'm copying the output of that list into a file. Okay, so I'm going to call it my files.txt. Okay, so now I go back on my Edge drive. I have a document which has been created just today, which is called my files. I double click. Now I have a document with everything in a text format. Okay? Very basic, very easy to do. Can be very useful as well. You know. Or if you want to change the priority of some files, you want to make sure that only some people can access to it. Yeah. That's the best way to do it. You know. That will be the most efficient. And that's what basically the IT support people everywhere are doing. Okay? There are a lot of applications for the type of jobs. Going directly to the operating system is the best way forward. And as you can see, it's not very complex. I just typed 10 characters and I got the outcome that I wanted. Okay, so what about Mac? Can you go to the dark side on Mac? Yeah? So how is the dark side on
Terminal.
Yeah, and how is it?
Um,
Is it dark?
yeah.
It's white.
Mine's black and green.
Yours is black, but the standard one, at least the last time I tried, the dark side on an Apple machine was white. So it's much more friendly. You know, already you feel much better. I mean, the Mac, the Apple operating system is based on Unix as well. Okay. I mean, they had their own for a while, and then they decided, okay, Unix did it well. Let's do our own version. Okay, so in this activity, I will ask you to explore those operating systems. So, first of all, I will ask you to go on the dark side on a Windows machine. So, everybody has access to Windows machine. Either you have your own, or you go to the library, or to any lab. You have thousands of Windows machines around. And I will ask you to type some different commands and try to get something similar to what I've just done. Okay? So for you to get a practical experience of working in that environment. And also I think it's just to demystify it, because when you have never done it, you think, wow, looks scary. You know, I'm used of nice Windows and I can double click, and now I have this black screen with this keyboard and I'm back to the 80s, what's happening? No, it's not complex, and you can get the basics quite rapidly, and you need to be able to do that. And then I want you to do that on your Linux machine. Okay? So if you have completed the activities, you have a Linux server by getting the Apache, your website on an Apache architecture. So now you can go on that machine and do the activity. I know that some companies doesn't allow you to go there. Okay, they don't trust their customers and say, okay, if they start messing at that level, they're going to break everything, and they don't want to invest too much in their support service, so they just bar you to do it. Okay. But most of them will allow you to do it. Okay. So if you are in the case where the system you bought doesn't allow you to have access to the server, just send me an email and I will give you access to another one. Okay. So that you can complete the activity anyway. Yeah. I think that's all I wanted to tell you today. If you have any questions, I'm very happy to answer them. Otherwise, next week is reading week, or there's no class next week. And in 2 weeks' time, I guess Pushpa will be back for